Okay, this is section 9.7, and it is taking the ideas that we've been developing with trig around sine and cosine specifically, and it's applying them to triangles that aren't right triangles. And so up till now, we've been working with 90-degree angles in triangles, and now we're going to take these same ideas and try to stretch them to triangles that aren't right triangles, and we're going to look at three specific ways to do that. And we're actually going to split this lesson into three pieces. So the first piece of this lesson is going to talk about area of a triangle. So in our notes template, that's this first idea. So this area of a triangle idea that's on the first page of the notes template. And what it's saying is the area of a triangle is 1/2 the product of two sides times the sine of their included angle. And they give you three equations here. Half BC sine of A, half AC sine of B, and half AB sine of C. And if you notice in each equation, they all have a half, they all have two sides, and they all have the included angle between those two sides. What I mean by that, and I'm going to ask that you redraw the triangle so that you kind of redraw as best we can this triangle A, B, C, where we've got a little side C, little side A, and little side B. And you can see they're using capital letters for the angles, and they're using lowercase letters for the sides. And that's just convention when we're dealing with triangles. And what we're talking about is, let's look at this first equation specifically. We're looking at the area and we're defining it in terms of the sides, B and C, and then sine of A. So that's that angle right there. So there's our two sides and the angle that's in between them. And each of these equations work that way. It's just looking at two different sides and the angle in between those two sides. And so what I'm going to do is show how this works for this specific first equation. The same idea can be applied to the other equations. In order to find the area of a triangle, we actually know how to do that without using all of this stuff that's up here. The area of a triangle is half base height. So 1/2 base height. And in this case, if we define the base to be little b, then we've got our half and we've got our base, we'll call that little b, and then we've got our height. And the height is this dotted line that drops from the top. We call it the altitude. And what happens is it hits the bottom at a 90-degree angle. So what I'm going to do, and I'll switch colors to do it, is I'm going to look just at that one triangle. So that one right triangle that has our 90, our H, little side C, and then our angle A. And I guess there's a B up here too. We don't really need the B, we just need the A, the H, and the C. What we can do is then say, okay, well, sine of A is H over C. Sine of A is opposite over hypotenuse. So on this right triangle, this one right here, we can do sine of A. We know how to do sine with a right triangle. Then I'm going to take and multiply both sides by this C that's on the bottom. So I have C times the sine of A is equal to our height. So that's an expression for the height of the triangle. If I then take that and substitute it into our area equation, I've got half times B, that's our base, times height. And height, we just said, is C times the sine of A. So if I take and put that right here, what I'm going to do is end up with an equation for the area that's half B times the height. But the height is C times the sine of A. And that is the focus today. That is this equation up here. So the C times the sine of A, this thing, that just is the height of the triangle. And the 1/2 times the B, that's our base, comes from the first part of the area equation. So that's where this thing comes from. When it all comes down to it, you just have to know how to use it, but I think it's important to see where these things come from. So next what we're going to do is let's go ahead and use it. So I'll change colors again. I'll go back to black, and we'll go to the third page of the notes template. And we're actually going to jump down to question number 4. So we'll look at question 4 on the third page, and it's asking us to find the area. And it's shaded in the triangle to tell us we're finding area, versus you can see on 6, 7, and 8, these unshaded triangles are asking us to do something different. But on 4 and 5, they're trying to show you as well as put it in the directions that we're finding the area. And to find the area of a triangle that's not a right triangle, we can use half AB sine of C. Well, that would be the two sides, 14 and 9, and the sine of the included angle. So that would be 1/2 times 14 times 9 times the sine of 79. To do that, we don't have to do individual pieces. We can do the whole thing in our calculator. So let's jump over to the calculator and let's do that. Let's go half, and I'm going to do half with a 0.5. That's our decimal for a half. Times 14 times 9 times the sine of 79. So I'm just typing into the calculator that string of numbers that we just had, our half AB sine of C, or a half times 14 times 9 times 79. I'm going to hit enter, and that's it. That's our area of the triangle, 61.8, if we're rounding to the nearest tenth, which they're asking us to do here. So we'll jump back here. Our area is 61.8. And again, you can see the half, 14, 9 sine of 79. We'll jump back to the calculator. That's what I plugged in, and I got a 61.8. So using the equation, it's not too bad, particularly if you're given the two sides and the angle in between. So on number 5, let's try it again. So we've got area equals half times 19 times 22 times the sine of 24. And again, I'm not going to do that separately. I'm going to plug the whole thing into the calculator. And the only difference is, instead of the half, I'm just going to put it in as a 0.5. So let's jump over to the calculator, and I'll clear out what I did here, and I'll clear the key press history. So now we'll go 0.5, and we'll go times, we said that was 19 times 22 times the sine of, and we said that angle was 24 degrees. And then I'll hit enter, and that's it. Our area is 85.0. So I'll jump back to our sheet, and I'll say our area is 85.0. And that's really it. That is using this new formula for the area of a triangle that, instead of using the height, incorporates this sine to get the area of any triangle. And as part of this lesson, I'm going to scroll up now. As part of this lesson, we're also, and this is a second idea, so this is related to the area, but it's a second idea that you can actually do sine, cosine, and tangent of angles that are bigger than 90 degrees, that are obtuse, or even bigger than 180 degrees. And they have values. We need this fact to do obtuse triangles in this section. And the reason it works is actually part of another course. So either Advanced Algebra Trig or Analysis, depending on which course you were to take. For right now, what you need to know is that your calculator can compute these things. So we've got sine of 225, cosine of 111, and tangent of 96. So we'll just plug those into our calculator. So let's see. Again, I'll clear this out, and I'll do sine of 225 degrees. Again, up till now, we've only been doing acute angles, but we can do angles that are bigger, as big as we want, actually, and we hit enter, and it gives us this square root 2/2. So I'll change my fraction. I'll change my fraction to a decimal, so let's try that again. So we'll do sine of 225, and I'll close my parenthesis, hit enter, and I think on this calculator I just hit second table, and I get a decimal, so it's negative 0.707. So I'll jump back, and we'll do negative 0.707. It's actually asking for 4 decimal places, so that would be 7071. And that's it. So again, the idea of these 3 problems is just, hey, you can do angles bigger than 90 degrees. Your calculator knows what they are. The topic will be covered in a future class, but there will be specific places where we need this information. So let's do cosine of 111. So if we jump over here, we'll clear this out. We'll do cosine of 111, and we'll see what our calculator gives us for that. And it gives us negative 0.3584. So negative, and that's just rounding this last 3 up. So negative 0.3584, negative 0.3584. And the last one, tangent of 96. Again, going to our calculator, guess I don't have to keep clearing it out, but I will. Tangent of 96, and we hit enter, and that gives us negative 9.514. Actually 4 decimals, so negative 9.5144. Negative 9.5144. Let's just make sure I got that right. Yep, negative 9.5144. So again, idea here, you can plug in values above 90 degrees, and your calculator knows what they are. The reason why will be a future course. The way we'll use it, and actually I'd like you to, if you have space, either kind of up here or down here, pencil in one more example. I'm going to put it over on the side on this screen. But if we have a triangle that's obtuse, so something like that, or maybe this angle is 115 degrees, we've got a side of 10 right here, and maybe we have a side of 12 right here. If you want the area of this triangle, right now the two area examples they gave us used acute angles, but you see the same setup. We've got two sides and the angle in between. So if we wanted to find the area, so say this was the next question in this string of area questions, so we have 4 and 5, this one sets up the same way. You just do half sine of the one, I'm sorry, let's match the way they do it. I'm kind of moving too quick on this one, so I'll slow it down. It's half times 10 times 12 times the sine of 115. Again, up till now, we haven't talked about being able to do something like the sine of 115, but we can. So let's plug that into our calculator. So we'll jump back to here. Again, I'll clear this out, and I'll clear this out. And we're going to go 0.5 times the, let's see, the 10 is the first side, times 12 is the other side, times the sine of, and we said we're going to use 115. And hit enter. And there's our area, 54.4 if we round to the nearest tenth. So our area is 54.4, and you can do it with obtuse as well. So that's the point of these three exercises, is just to indicate, we can do obtuse angles using sine, cosine, tangent. The reason it works, it does get pushed off to a future class, but that's okay. That's a lot of mathematics works that way, where we develop ideas, we use them in one class, talk about them in another. So just know that you can do it, it's there, it occasionally gets used, and your calculator can make it happen. So area of a triangle using half AB sine of C formula is the first part of 3 for section 9.7.